discrete port. And that's good to go, because it automatically uses the points. That's why I like to pick points. Okay, now we need to set a frequency. I had 0.5 to 4 or something, didn't I? The background is normal, that's cool. The boundaries, open add space, we're good. So it looks like open add space is the default boundary position. But it's still a good idea to check, just to make sure. Because there's nothing worse than having really screwy results and having just a bad boundary condition. Because there's no way you figure it out unless you check that. Okay, now, post-processing. We want to measure an S parameter. This is the first S parameter you guys have made. This S11 is like a reflection coefficient. So here's what we're doing with this S11. We're going to see if we're designing for 1 gigahertz, S11, what's the return power? How much power is reflected? Gamma squared, right? So if the power is going up the antenna and being reflected, okay, if it's being reflected, then if reflection coefficient is 1, all the power is being reflected, apparently it's not being radiated. So around 1 gigahertz, we'd expect the reflection coefficient to be smaller, 5 bits smaller than 1. See what I'm saying? Because we want some of the power being radiated. So that's good. That's good. Close. We want to do field monitors, and I'm just going to use the default thing. You'll have to use whatever frequency we say. Apply, and also a far field. And let's say we wanted 1 gigahertz, didn't we? Apply, E field at 1 gigahertz applied, H field 1 gigahertz applied. How many things do we have? Far fields. Okay, that's good enough. And now we say we press go. And it's 635,000 mesh cells, so it's going to take a bit to run.
Why did you pick 2.25?
It comes up default in the middle of it. So,
the middle of your screen.
Yeah, I mean, when you say the middle way between 0.5 and 4 is 2.25. And that's what it comes off automatically, depends on the frequency range. Yeah, here.
What did you pick in the template-based post-processing?
Oh, the S parameter. S parameter.
It's never on top of it.
Choose S parameter.
I don't know how to-
S11. Here, I'll show you. I'll show you on the other one. I wonder if it'll let me open it.
We'll be able to figure it out.
This is the one I've already had made up.
There's no way you can follow along.
I have a hard time doing 2 things at once.
No way in hell. Yeah.
And the S parameters will be right here. The post-processing S parameters will be down the tables. So down here, table S11. This is the S11 is kind of like a reflection coefficient. Okay. And notice here's the real part. I want to get the magnitude, so I'll click linear up here. And notice it gets pretty small around 1 gigahertz. I haven't messed with it. So if I was really doing this, I'd want to get this sharp point over here someplace. I'd want this sharp point down here over at 1 gigahertz. This right now is kind of, it's pretty close to 1, not bad, around 0.9 gigahertz or something. It's really radiating well because none of the power is, hardly any of the power is being reflected because 0.2 squared is 0.04, so 96% of the power from the source is getting radiated, and that's not bad. See what I'm saying? Now you see how it's going down again up here? This half wavelength, this is probably some other half, some kind of odd number. Let's see, 1, this looks like 3 halves wavelength, doesn't it?
Yeah. Move over.
Yeah, I just changed the wave order.
Okay. Along with the
What's the coverage? Starting higher.
Oh, yeah. This is the coverage on the test on Tuesday is transmission lines. No antennas. No quasi-static, so transmission lines. But there's lots of stuff in transmission